does it?
It looks good.
Right. Hello. Sorry about that. I'm Francisco Dans. I work for CartoDB as a rendering developer. And my talk is called CartoDB and the New Spatial Technology Paradigm, which is a title that I did not choose. And I actually like the one that is in the bottom, New Ways of Exploring and Explaining Data. So for those of you who don't know CartoDB, I'll spend some time talking about our company. We're a geospatial company that is based in Madrid. We were founded as a spin-off of a visualization company called Visuality. It's okay, the sound? Cool. It started with a series of projects by Visuality as a consultancy that later evolved into a product to import data from any source and turn it into a visualization. So this is the sort of the three branches of services that we provide. We have a connection location data systems. So we have a set of tools for people to import the data in several ways. If you need to visualize your Instagram pictures, we have a connector for Instagram. If you have a company that uses Salesforce to locate the clients and manage them, we have a connector for Salesforce. If you just need to drop your table or you want to connect your database to CartoDB and visualize your data, we have that too. You don't need to have even coordinates. We have a geocoder that will turn the addresses and IP addresses and all that stuff into coordinates for you to show them in a map. Okay. Well, that's the first part. Then there's the visual data discovery, which when all of that data is imported into CartoDB, we have the tools both in client and in the server, to turn that into very, very beautiful visualization, which is what I'm going to try to show you in a few examples during this presentation. And also then, this is the part that we've been working the most in the last few months, and we're expecting to do a few releases in the coming weeks, which is Cloud GeoAnalytics, which is not only, we've passed the point of just visualization and just gathering insights from your data just by looking at it, but also we're making inferences and making you get conclusions, factual conclusions from your data using statistical analysis. And how do I move? Okay. Yeah, so introducing the product, I always like to show this map because you remember this this scandal that happened a couple of months ago with Ashley Madison. There was this website that was designed, I'm throwing someone's papers, that was designed for people to have an affair. So it was all a social network, sort of like OkCupid, but just for people who wanted to cheat on their partners. And they had a massive security breach where some hackers threatened them if they didn't close their website, because ethical reasons, they would release all of their customers' data, which would imply millions of people getting caught by the partners at the same time. And that's exactly what they did. So I actually have the map here because the most infuriating, well, it's not the most infuriating thing about them, but there's a curious thing that an allegation that not only the website was insecure, but also most of the female profiles were fake by a large margin. So this map created by some guys in Sevilla called Tecnologica showed which points, which places, which cities had less than 85% male population, which is already a pretty bad proportion for anyone looking for a female partner. But also, you see how many places, like Ashley Madison was trying to get, made a lot of fake profiles and still didn't get any market penetration. For example, here in Japan, because there was more than 85% male profiles, which we assume they're not fake, because, yeah. But we see that that means that Ashley Madison succeeded in getting people to subscribe with those fake profiles. But But in India and in Philippines, regardless of how many fake profiles they open in the country, they didn't get people to sign up on the website, which I found pretty interesting. So going back to this thing, so what we try to do is enabling people to tell stories. And at the same time, and this is the other side of the spectrum in our clients, gathering insights from the data by taking a look at them from a different perspective. This is my favorite project in CartoDB. I'll show you a live example. So this is Global Forest Watch. A few years ago, there's this organization called the World Resource Institute, who has this product called Global Forest Watch. This is basically an animation application, an application that has animations that show almost in real time where forests and landmass that are covered by trees are being repopulated or depopulated. So I was focused in Spain, but if you see, so there's the blue points, which mean that the forest mass has been repopulated, and there's the purple points, which means that the points have the land mass has been removed. And for example, in Indonesia, there was this big problem where palm oil corporations were trying to scare tribes off their homeland by setting fire to the forest adjacent to the tribes, to where the tribes were located. And thanks to this tool, they were able to kind of unmask the corporations and publicly denounce those acts. And let's go back to the presentation. And this is done with no, I didn't want that. Okay. And everything is going on. And this is done thanks to a technology called Torque. Torque allows us to get a lot of data. This is millions and millions of points in a database. And without the use of WebGL or anything that depends on the GPU or is too technically advanced for many people to maintain and contribute to, we are able to display many points. Excuse me, I'm going to go back. You see that if I get close to this is not polygons or anything like that. This is individual points that have been collected by satellite imagery. And this is all possible because we have a server displaying a special kind of tiles that is different to the traditional map tiles. And I'll show you a bit about that right now. And because that's what I do in CartoDB, I do client-side rendering without WebGL. And I'm going to talk about what that means, client-side rendering. First, I usually like to speak about what client-side rendering involves. Rendering is a word that many people use, but it's a bit difficult to define it usually. So about 2 months ago, I had to give a talk to my school from when I was a kid about CartoDB. They invited me to give it, and I draw this. Basically, this is the process this is what I call rendering, which is just having some data, which is someone saying that there's a tree in Italy, and then there's a process in the middle that is called rendering that turns that into an image, and that to me is rendering. And the most important part of our client-side rendering stack in CartoDB is Torque. And Torque, as I was saying, is a library that allows people to get large amounts of data and display them not only in an aggregated way, allowing people to show loads of points, but also make them animated. And I I love this example. This is something that came up when I started working in CartoDB. This is a guy from the Washington Post that got GPS tags on dummies and went to Alcatraz prison and released the bodies in the sea at different times of the day. And basically, this is the animation with torque of where the bodies went following the different times of escape at different attempts in history. So to model what happened with them. So some of them just went off to the Pacific Ocean. Some of them, you see that as the currents, as the streams switch, they start to move a bit slower, and then they turn back. And actually, there's a police station here, and you see that some of the attempts go back to the police station. And yeah, and then there's some that go back to, you know, Silicon Valley and stuff. So I like this because it's a fun way of, because people usually in the mapping startup sort of environment associate talk only with this, which is an example I really like, but people usually only see this. This is a Twitter map of people saying sunrise in their tweets. So you see that we've matched that with the time zone date. So you see that when the sun is rising, there's a lot of tweets saying sunrise. And especially in Europe, and you see now in the United States, everyone is saying sunrise. Yeah! And people associate torque maps with this visualization, but it's not only that. It's also a very good way of visualizing time and making stories a bit more interesting by adding a spatial component to them. Yeah, I was talking about that. Yeah, that's a GIF that is way worse. There's a lot of non-profits use us to visualize a lot of points. For example, this is I don't know if it sounds familiar to you, but the Ellis Act, and they try to visualize all the San Francisco families that were forced out of their homes between 1997 and 2010. The thing is that I think the last time I accessed this, the map was down. Oh. Yeah, so you see that over time. See, and there's at some point where the act is approved, and the rhythm at which people are forced out of their homes goes up. And the size of the marker marks the amount of evictions in a single place. I like this one very much because it's in Germany. Where do birds go, depending of the time after sunset that they depart in, and the blue particles is the wind. There's a lot of really fun examples if you go to the CartoDB website. So there's a complexity with animated maps. The thing is that you can't use traditional data formats for animation maps because it's too heavy and too difficult to translate into graphics. The problem, for example, if you're familiar with GeoJSON, you see that it's too verbose a format, and it has too much data in it. For example, it has latitude and longitude information that implies that in the client, when the browser receives those data, it will transfer latitude and longitude into a pixel point. That's very inefficient if you want to visualize millions of points in a browser. There's another part that, you can't put 1,000,000 points in a tile. That's impractical if you don't want to use a very complex solution like WebGL. And that means we have to use a very smart format that we call the data cube. Well, there are several variations of this name. There's tile cube, there's data cube, there's time cube, and in this case, it's data cube. Which means that we have, instead of a tile that maps are usually divided in, we have a cube, which means we add a spatial variable to the data we render. And then we don't have latitude and longitude, we just have X and Y points within that tile, which makes sense because PNG tiles are sort of the same. PNG tiles are files that just have pixel information. They don't have a latitude and longitude. That's only in vector rendering. And then there's in the server, in the server that serves these tiles, there's also another factor, which is the aggregation. When you ask for a door data cube in the map, it will return an array of points that is not that doesn't correspond to latitude and longitude, but it will be binned in tiles. Sorry, not tiles. In columns and rows instead of being exactly that position. So it will aggregate the positions to be able to. Sorry, yeah, that's the thing. So instead of latitude and longitude, you get arrays of positions within a 256 by 256 tile. And this is a bit how the timing works. Instead of giving dates and giving, we give positions in time by calculating a number of steps with the starting date and the ending date. How are we doing on time? Okay. This also allows us, this is also all rendered in the client. We use we use CartoCSS, which is a language based on cascading style sheets that was invented by Mapbox, I think. You guys invented it? Yeah. But they're not using it anymore. And the way that it works is when you declare a torque map, a torque layer, you just set up a number of factors like how many frames do you want your animation to have, or and how much time does your animation take, and then the column that you want to set as time in your database, in your table, sorry, and the aggregation function. So what do you want to show? If you have a map of how many trains have crashed in the last year, I don't know why that example came to my mind, but I'm sticking with that. You probably want to aggregate maybe the number of I don't want to say number of casualties, the number of coaches that were involved or something like that. Then there's the torque resolution, which is what I was talking about. Instead of aggregating those, if you have millions of points, you don't want the server to return 1 point for each pixel, that resolution. In this case, for example, it's 16, which means there'll be a point, the server will return a point value aggregated by the number of trains per 16 pixels. And that compresses the data a lot and makes using that data by the client, which in this case is a canvas renderer, much simpler. Well, this is a bit of how CartoDB is organized. You see, you see here torque, which sits between the Maps API and the SQL API. Torque has to query the Maps API to get the tiles, which makes the SQL API convert, the tables and rows and all that data into a tile. And I just want to add this slide. That I didn't make this one to locate our library within CartoDB. And I'm the main maintainer of Torque and the whole client-side library stack in JavaScript. But I like very much that we have. I didn't do it, but we made Torque in a way that the renderer is very detached from the data. So anyone that is new to the library can get into the can get inside the repo and just create a new renderer. And there's very nice examples of what people have done with this. For example, there's this data set of all the boats that sailed during the First World War and the loggings, like temperature, location, how was the weather, and collected by the Royal Navy between the 13 and 25. And using that aggregation technology by the server, we're not in this case we're not displaying points and locations, animations, but a guy from the solutions team in CartoDB converted that into this sort of heat map. There's also he also got the wind directions in those meshes and changed the renderer so that for each measure it would display sort of a needle of a canvas depending on the wind direction. And also, these are some tests with several variables. You know that I explained earlier that you had to choose one to aggregate into. This takes several. And these are some tests that are made by changing those points into ISO lines and getting similar values to belong to the same ISO band or ISO line. And also this is something made by Javi Santana, which is an animated Voronoi diagram. I'm not sure what the data set of this is. And oh yeah, this is the original. This is the original data set of the boats that were sailing during the First World War. This is one of the first examples of torque that there is, and I suggest you open the repo and create a renderer. It's really simple. It's just if you have some experience programming, you can just there's just a method to receive the tiles and render them on the go. And yeah, thanks to all those people, Andy, Javi. Well, Andy actually ripped part of his presentation off for here, so a special thanks to him. Then Javi Santana Sterling and Aurelia Moser for helping with this. Also, I want to point out that we are hiring, so if you know anyone or you're interested in working in Madrid or New York, come talk to me. We have openings for pretty much every aspect of the company. Thank you so much.